right, we're going to start chapter 13, and we're actually going to start it in section 8.5, which I know doesn't even sound like it should be like allowed. You shouldn't be allowed to do that, right? And yet, that's exactly what we're going to do today. We're going to break the rules. All right, what we're going to look at today is we're going to look at equations in the coordinate system, okay? So we're going to look at graphing, we're going to look at lines, we're going to look at x and y coordinate pairs, things like that. So let's start with the coordinate system, some things that you maybe have forgotten, maybe you haven't, but just some vocabulary. All right, so our coordinate system is split up into 4 quadrants. Quadrant 1 is on the top right-hand corner, and then you go counterclockwise around to get quadrant 2, 3, and 4. Does anybody happen to know the reason for that? Has anybody told you that before? It is counterclockwise, which is sort of not intuitive. The person who labeled our coordinate systems and the one that we follow is actually left-handed. And so that was the direction that he moved around the circle, basically, around the coordinate plane. The point in the middle, 0, 0, is called the origin. The horizontal axis down here is called the x-axis, and the vertical axis is called the y-axis. Okay? So any other place that you are in this coordinate system, say we're right here, there we go, has a location that we can identify by an ordered pair. And we always list it with x first and y second. So x is the distance you move horizontally, outwards, okay, horizontally. And so how far horizontally did we move to get to my red point? 4. And we moved 4 because on this side of the graph, it's the positive side, and the left-hand side is the negative side. So if we move to the left, we'd say we moved -4. I mean, I know we still moved 4, but it was 4 left, okay? And then the y value is how far up or down you move. So again, when you move up, we say we moved to positive value. You move down, we say we moved to negative value. So where are we at this point? -1. Okay, does everybody remember the details about this, okay? All right, fantastic. All right, a point in the Cartesian, we're just going to kind of go through these notes quickly because I already said most of them. A point in the Cartesian coordinate system is given by the ordered pair AB. A is called the abscissa, I'm not saying that right, but anyway, it's the x coordinate, it's what we call it. And then the second coordinate is the ordinate or the y coordinate. Okay, I already gave you an example, so we'll skip there. If we plot all the points that satisfy a given condition, the resulting picture on the Cartesian coordinate is called a graph. So sometimes our graphs are lines, sometimes our graphs are circles, sometimes our graphs are parabolas or cubics or square root, and they have all these different images, okay? But that resulting picture is called a graph. So when I say graph, I don't mean the axis. The axis is not the graph. The axis is just a way to locate where things are in space, or on, in this case, on a flat surface, okay? So the axis is not the graph. The graph is the picture formed by points or curves or lines. All right, the graph of an equation x equals a is a vertical line, and any vertical line has an equation in this form. That is, any vertical line is x equals a number. X equals a number. Why? Well, the reason why is because all points in the blue line have coordinates. What? What can you tell me about all of these points that they have in common? Every single one of them, their x coordinate is 2, right? That's why it has the equation x equal 2. Because every point on the blue line is 2, and then it's some other number. It's 2, 5, it's 2, 10, it's 2, 3.17489, starting with 2. So this equation for this line would actually be the equation x equals 2. So far, so good? All right, so I guess my notes used B here. I'll put B instead of just the number symbol. B, where B is a real number. All right, that's vertical. We also have horizontal lines. Horizontal, you can remember, is like the horizon, okay? Horizontal lines. Horizontal lines have the graph, or the graph of them has the equation y equals b. Because what can you tell me about every point along this line? has the same y value, right? And in this particular equation, it's y equal 3. Because every point on the blue line has some x value, we're labeling it a, and then it has a specific set y value, 3. Okay, so like vertical and horizontal lines are very specific types of lines. Most of our lines are not those kinds, right? Most of our lines have some sort of a tilt or slant to them. Agreed? So that's where we're moving next. We're looking into the lines that don't have that form. So in general, lines that are not vertical, and actually horizontal lines have this form too, but it looks a little bit different. Lines that are not vertical have the equations that can be written in y equal mx plus b form. This is called the slope-intercept form of a line. What in that equation is the slope? M. And what in that equation represents the y-intercept? B. And really, the y-intercept should be, hang on. I had it written right the first time, 0. There we go, B. It's an x value of 0, it's a y value of b. That's the y-intercept. Any equation that can be put into this form, so no matter how it begins, you can turn it into this form, or into the form x equal a, is called a linear equation. Linear equation, another way of saying line. It's a graph, its graph is a line. Say it that way. All right. Y-intercept, this is what I just wrote on the other slide. A y-intercept is a point with coordinates 0, b. It tells us how many units above, if b is greater than 0, or below, if b is less than 0, of the origin that where our graph will cross the y-axis. And the x-intercept's the same idea. Its coordinate pair is a0. It's the location where we cross the x-axis. It's how far left or right we have to go to cross the x-axis. So when you're looking at the equation, graph, and let's say that it looks like this, then this point right here would be your y-intercept, and it has the equation 0, b. Okay, height of b. The distance is 0 from the from the y-axis. And then down here, it has the coordinate pair a, 0. So a is how far left and right you go from the x-axis, y-axis, I keep saying x, from the y-axis. And then the 0 is how far up and down you went, and you didn't go up and down any from the x-axis, so it's a0. Now the slope is the rate of change in the y values in relation to the corresponding x values. So a positive slope we'll say it this way, it rises from left to right. We always read our graph from left to right. It rises from left to right. A negative slope, what does it do? We'll always read it from right to left, so I mean from left to right, so I don't want to change that part.
So
It lowers or it decreases. So you could also use the word it falls. It falls from left to right. Zero slope is flat, right? That's a horizontal line. What does no slope mean? That's zero slope still. Horizontal line is zero slope.
no slope would be it stays on the x-axis, right?
Nope, x-axis is a horizontal line as well.
Okay.
Okay, Emma, say it louder. Yeah, it's vertical lines. No slope or vertical lines. We would consider that to have no slope. So no slope happens when the slope is undefined. Let me show you in terms of how the problem actually works out when you try to find it in a little bit. But this is an undefined slope or no slope, and this happens for vertical lines. I learned an acronym somewhere along the way that I thought for some people is awfully helpful. The acronym is HOIVUX. Has anybody ever seen the acronym HOIVUX? I've actually only seen it one time by a fellow teacher who was teaching this, and I thought that's pretty clever. So let me tell you what each of those letters stand for. It's an acronym, right? Like PEMDAS, okay? H stands for horizontal. Let's write horizontal. O is actually the number 0. It's a number. Okay, so horizontal, 0. And then the Y is the equation Y equals. This is 0. This is horizontal. Any guess what V might be? Vertical. What do you think U is? Undefined. And X is X equals. What HOIVUX says is that horizontal lines have 0 slope and equations Y equals. Vertical lines have undefined slope and equations X equals. Kind of condenses it all into one acronym for us. Slopes that are farther from 0 are farther from horizontal or steeper. So bigger numbers give you steeper slopes. If you have two parallel lines, they will have the same slope. And it says the exception is vertical lines, which is sort of a language issue. Vertical lines don't have slopes. There is no slope. It's undefined. But if you had two vertical lines, they would have both undefined slopes. So the representation of how you think about their slopes would still be the same. And so if you take a look over here, this picture, you see several lines, and they're all parallel. And the reason that they're parallel is because their slopes are the same. Right? They will never intersect because they have the same slopes. So let's actually use slope formula now. Slope formula is the change in y values divided by the change in x values. Sometimes thought as the vertical change over the horizontal change. Rise over run. If you're dealing with ordered pairs, you can actually do y2 minus y1 over x2 minus x1, as long as the x values are not the same. So think about your horizontal lines. On a horizontal line, every x value is the same, right? So what would happen to this denominator if you plugged in two x values that were the same? We get 0 in the denominator, and when we have 0 in the denominator, that is an undefined value. Hence, the slope being undefined. When you try to calculate it, you get 0 in a denominator or something. In terms of your picture, you can see the rise and the run. So we've got this blue line here, and then on the bottom here is marked how far left and right you have moved to get from here to here. And then over here is marked how far up and down, up or down, this one's up, you have gone to get to that next point. If you're given graphs, sometimes the easiest thing to do is to simply count, right? How far left, how far up you went. If you're given ordered pairs that are not on a graph, it's usually easier to do the subtraction and go from that perspective. All right, slopes of perpendicular lines. Again, as long as you don't have vertical lines. Then slopes are perpendicular when they are negative reciprocals of each other. Okay, so let's talk about the word reciprocal. What does reciprocal mean?
It's the opposite.
Yeah, this is what 3 of you were doing in the air when I said that you did this, right? It's when you flip a fraction upside down. We also call that the multiplicative inverse, if you've taken proportional and statistical reasoning. Multiplicative inverse. So if you have one slope, let's say you had the slope 2 over 3, what would the perpendicular slope to this slope be? Negative 3 over 2. So you do the reciprocal and you change the sign. What if the sign were negative to start with? You change it to positive in the slope that was the perpendicular slope. Okay, so we're going to do an example. It says to find the equation of the line through the point negative 4, 2, that is perpendicular to the line y equal 2x plus 1. So let's start with this line. This line has a slope. What is the slope of this line? 2. So what would the slope of the perpendicular line be? Well, it'll be negative, but not 2. Negative 1/2. Right? Because 2 is like 2 over 1, so when I flip it, I'm going to get 1 over 2. So this is the slope that I want for my line that I'm working with. And I've got this point that I want as well. So I'm going to show you 2 ways to find lines. I don't care which one you use. The first way that I'm going to show you is using exactly the information I've shown you so far. That is, the only line that I've written so far in this presentation is y equal mx plus b. And legitimately, you can learn that line only and do everything. You don't have to have any other forms of lines. So what would you do? Well, you'd plug in the m value. That was negative 1/2. And you'd plug in the values for x and y. So what is the value that they give you as the point that you're going through for y? 2, right? What's the value they give you for x? Negative 4. So am I going to be able to solve this for b? Yeah, because that's the only thing that I still don't know. So this is 2 on the left. What is negative 1/2 minus times negative 4, excuse me? That's also a 2, yeah? So what does b equal? Happens to equal 0. So this is my b value. I already had my m value, negative 1/2. So this, be careful, like when I plugged in the 2 and the negative 4 here, that was one specific point. I'm looking for the equation of the whole line. So my answer will not have the 2 and the negative 4 plugged in. Okay, is everybody all right with that? It will not have those values plugged in. It will have the m value plugged in, negative 1/2 x. And it will have the b value plugged in. And if you don't want to write the plus 0, just leave it off. That's okay too. But this would be the equation of my line. It's handy in the sense that I only have to remember one form of an equation. It's not so handy in the sense that it's a 2-step process. That's not quite as friendly. So there's one other way that you can do this. There's probably more than that, but there's one other way I'm going to show you. And the other way you can do that is by knowing another equation of a line. It's called the point-slope form of a line. Okay, are you guys familiar with that one? Yeah? Okay, so in the point-slope form of a line, we can actually plug in the x value, y value for the y1 and x1. So this would be y minus 2 equals, and the m is the negative 1/2. And then you have x minus, was it negative 4? Yes. So x minus negative 4, x plus 4. And then we can solve this for y. All right, so we've got y minus 2 equals negative 1/2 x. And then negative 1/2 times the 4 would be negative 2. And then we add our 2 from the left to the right. And of course I still get the same equation, y equals negative 1/2 x. Different perspective, same result. Okay, pick your favorite. Okay, this one says timeout. We're going to work through these together. So suppose that these points are on a line. Find the slope of the line and the equation of the line. We're going to do these one at a time, but so let's just pause and we're going to do number 1. So we have this point and this point. Part A is to find the slope, and part B is to find the equation. So how do I find the slope when I'm given 2 points?
y1 minus y2 over x1 minus x2.
Good. We use the slope formula. So these are my 2 values. And this is the equation that you remember. So it doesn't make any difference if you call the first one x1, y1 or the second one x1, y1. Because when you subtract, you just need to keep them in the same order. So just for the sake of simplicity, I will call the first one subscripts 1 and the second one subscripts 2. All right, so y2 is actually 0 minus y1, which is 6, over x2, which is 7, minus x1, which is negative 1. So what will this simplify to? Negative 6 over 8. Does that reduce? Yeah, to what? Negative 3/4. Okay, so this is part A. Part B wants me to create the line through these points. So to create a line through the points, we need the slope, like we just said, and we need one of the 2 points. It doesn't matter which one. No matter which one you pick, you're going to get the same equation when you're done. So which one would you guys like to pick? The first one or the second one? All right, second one it is. I like the second one better because it's got a 0 in there somewhere. 0 is a nice value to work with. So I'll use that y minus y1 equals m times x minus x1 form, point slope form. So this is y minus 0 equals m, which was negative 3/4, times x minus 7. Lovely, I don't have anything to add from the left because it was a 0. And I just have to distribute on the right. So this is negative 3/4 x plus what? Three-fourths times 7. Thank you. 21 over 4. You guys are concerning me. 21 over 4. Multiplication of fractions. All right, question number 2 says, write this equation, 3x plus 2y equals 8 in slope-intercept form. Identify the slope and the y-intercept, and then find the x-intercept and draw the graph of the line. A lot of things going on. First thing was to put it in slope-intercept form. So the original equation was 3x plus 2y equals 8. So what do I have to do to put this in slope-intercept form? Move the 3x, right? So I'll subtract 3x to both sides. And then what?
Have to divide by 2.
Yep, I need the y alone, so I'll divide everything by 2, or each piece by 2 if you prefer to think about it that way. So this is y equals negative 3/2 x plus 4. The next thing we were supposed to do was to identify the slope and the y-intercept. So what is the slope of this?
Negative 3 over 2.
Right. And the y-intercept? Well, we're going to write it as an ordered pair. 0, 4. Y-intercept is 0, 4. Good. Knowing those 2 pieces of information, it's helpful, is helpful to begin to draw it. You don't have to, but it's helpful. So we could draw this now as it crosses the y-axis at 4. So like here. And it has a slope of negative 3 over 2. How can I use that to graph it?
We're going to go down 3 and over to the right 2.
Okay, so if I go down 3 and to the right 2, it puts me right here at 2, 1. Do you agree? And as long as I have 2 points, of course plotted correctly, I can connect them with their line. 2 is all I need. Now there's a catch in this one, right? Because they actually asked us to do one more thing. They said after we draw the line, I guess I did these out of order. It said to find the x-intercept. We could find the x-intercept to use that with a line as well. But we do need to find our x-intercept. How do you think we find our x-intercept? What can you tell me about every point on the x-axis that's the same? What's the same about every point on the x-axis? We did this before already, but not about the x-axis. What does every point on the x-axis have in common?
It's at 0.
What's at 0?
The intersection of it. Y.
Y. These are all xy pairs, right? Every point I plotted in red is an xy ordered pair. All of them on the x-axis have a y coordinate of 0, correct? So we can find our x-intercept by letting y equal 0. The x-intercept is when y equals 0. So in our equation, whichever form of the equation you want, I'll use the original form even. 3x plus 2 times y, which is 0 now, equals 8. If you want to use the y equals form, you can use that one. Doesn't make any difference. You're going to be solving this time, though, for x. So 2 times 0 is 0, so I have 3x equals 8. What does x equal? 8 over 3. So my x-intercept now is 8 over 3, 0. 8 over 3, 0. All right, there was one more question on those slides. What was it? Oh, this one's a really fast one. We can do it on the other slide, and we'll stop there. All right. It says, find the equation for the line containing 3, 5 that is perpendicular to the y-axis. Think visually. If you are perpendicular to the y-axis, what kind of line do you have?
It forms a right angle.
Okay, but what kind of line is it? Say that louder. It's horizontal, right? That's a horizontal line. If you are perpendicular to the y-axis, your line is horizontal. Okay, so I gave you a cool acronym to remember. Does anybody remember it? HOIVEX. What do you know about horizontal lines? What does their equation look like? It's got 0 slope, and it's got an equation that says y equals, it's the HOI part, H-O-Y. The equation says y equals a number. What number does y have to equal if it goes through the point 3, 5? 5. Because that's this ordered pair. If you're having a hard time visualizing it, draw the picture. That'll be just fine. Your point is 3, 5. Right here. If you are perpendicular to the y-axis, you're right there. What is the equation of that? Y equal 5. Every point along that pink line has the y coordinate of 5.